afternoon. My name is Eric Burgles with BAYSPEC, and my colleague and collaborator Eric Lindner with IWSHM. We'd like to introduce and demonstrate a ruggedized FPG interrogation analyzer and tell you a little bit about how this technology evolved and came to this point. First of all, we're really glad the event is actually right here in the Bay Area for us. So this is like our fourth year, and we really appreciated everything the organizers have done to make this very successful. We've had a lot of great interactions over the last 4 years. Our technology actually came out of the telecommunications industry. Some of our investors are like companies like Cisco, Intel, JDSU, and we do 100% of our manufacturing in the US. So we're set up for high volume manufacturing. The hundreds of millions of dollars that went into this telecom technology is now finding new applications in fiber sensing. The way we can do this, the way we've been able to miniaturize this interrogator is through the development and telecom lasers, which are butterfly packaged, fiber coupled, the transmission gratings, which we make in-house, the detectors. 10 years ago at Stanford, no one has a digital camera. Now everyone has multiple cameras on a phone with 0 pixel defect and Moore's law. So we're combining all of these technologies and making something that is very miniaturized, about the size of your smartphone. And as you can see, the light is coming in and the wavelengths are being dispersed by the grating onto a detector array. So the beauty of this is there's no moving parts. And furthermore, we're hermetically sealing this optics block so we can operate this in the field -20 to +70 degrees C. And now we've been ramping up. We have 35,000 units in the field. Our customers are kind of all over the place. Some telecom, military defense, oil and gas, downhole drilling, biomedical applications, and a lot of very interesting new university research projects. And just briefly, those are some of our products. And now I'd like to introduce Eric, who can give you more insight into the ingredients.
Thank you, Eric. So from Eric to Eric, thanks for the words. And Eric mentioned it already. For every ruggedized interrogator, you need also a good fiber optic sensing fiber. And what I would like to talk briefly about is the way how we see the future of fiber break ratings for any kind of sensing, structural health monitoring. And I'm from the company FPGS. We are located in Germany and in Belgium, in Europe. And what I would call, for us, it's actually break rating 2.0. We are the company who's making so-called drawdown ratings. What are drawdown ratings? In principle, you know probably a break rating, which is a refractive index change, is suited as a sensor. But if you want to apply a break rating, if you want to integrate it in the production line, you always struggle with the mechanical stability of the grating itself, because it's manufactured mostly in handwork. You have to strip, you have to do different processes, and it's not really nice automizable with a nice fiber strength. What we thought about, what is the process of maintaining fiber strength and simultaneously be very flexible in the way of how we produce gratings. And the idea is actually quite obvious and also not the new. Why not writing gratings during the drawing of an optical fiber? And that's exactly what we did, or what we can do. We basically have our own developed preforms. We draw it to an optical fiber, and during drawing we are able to want at any position of the fiber, any break rating at any place, at any stage. And how does it look like? It's an automated process which gives us, actually it's round normally, not that oval shape, but it gives us the possibility to be really flexible, to write gratings by using only one shot and have arrays with hundreds to thousands of break ratings. What are some strengths? The biggest strength is, and that was our motivation at the beginning, to maintain the intrinsically strength of an optical fiber, including a grating. And that we actually prepared in a small demo here on the left side. And actually for you it's probably looking like a magic trick, because there's really something here in between. It's not that the ball is flying or something like that. And actually if you zoom in closer, a little bit up, here, move to my finger. So there's really an optical fiber in between, having 15 break gratings inside, and only this small tiny fiber of 125 micron is holding here a baton rule of 1 kilogram weight. Yeah? And if you zoom in here on the screen, please, you can see that there are really 15 sensors in a row in this fiber, and it's still able to survive that high mechanical strain. I will go back to Eric.
Just to mention, there are many different applications, biomedical, process control, energy, and on. So we welcome you to come by and discuss further if you have some ideas or applications you'd like to discuss. And we have on the tabletop over in Grove. Thank you very much.